Hello students, today I am going to start my 5th lecture on light, reflection and refraction. In our previous 4 lectures, we have studied about reflection of light. From now onwards, we will study on refraction of light. So what is refraction of light? Here, when a beam of light encounters another transparent medium, a part of light gets reflected back into the first medium while the rest enter the other medium. Thus, when light travels from one medium to another medium through a transparent surface, it changes its direction. This phenomenon of light is called refraction of light. So, we can understand refraction of light from this diagram. This is a transparent medium. The above part is one medium and the below one is another medium. When a ray of light falls on this transparent medium, a part of this light will reflect back and another part will enter the second medium, and that part is called transmitted light. So this incident light has divided into two parts. One has reflected back to the same medium and another has refracted to the another medium. So this phenomenon of refraction of light, means traveling a light to another medium, is called, this phenomenon is called refraction of light. So ইয়াত মই কি বুজিলো যে এনেকুৱা এখন ট্ৰান্সপাৰেন্ট মিডিয়াম এখন লৈছো, এই ইনসিডেন্ট ৰে এটা এই ট্ৰান্সপাৰেন্ট মিডিয়ামখনৰ ওপৰত পৰিব দিয়াৰ লগে লগে এটা ৰে ৰিফ্লেক্ট হৈ যাব সেম মিডিয়ামত আৰু আনটো ৰে ট্ৰান্সমিট হৈ যাব এটা বেলেগ মিডিয়ামত। সো এই যে ট্ৰান্সমিট হৈ যোৱা ৰেটোৰ কথা যদি আমি পঢ়ো, তো সেই ট্ৰান্সমিট হৈ যোৱা ৰেটোক আমি ৰিফ্ৰেক্টেড ৰে বুলি কওঁ। আৰু এই গোটেইখিনি ফেনোমেনন যেটা ইনসিডেন্ট ৰে আহিলে আহি কেনে সেকেন্ড মিডিয়ামটো ভিতৰলৈকে সোমাই গ'ল, এই গোটেই ফেনোমেননটোক আমি ৰিফ্ৰেকশন অফ লাইট বুলি কওঁ। So this phenomenon can be easily explained if a coin is placed in a bowl containing water. The coin will appear slightly raised above its actual position due to refraction of light. So the refraction of light can be easily studied with the help of one example. So first let me take one bowl, and in that bowl I will put some water. If I will place a coin in that bowl, we will see that the coin will be a little above than the actual position. This is nothing but the refraction of light. At a bowl loisu, bowl tut moi eta coin pelai disu, pelai diar loge loge coin to jitu actual position, moi tar coin to actual position e nedekhi coin to olop man uporot dekha pam, aru hetu beleg ekku nohoy refraction of light or karone. So now let me study refraction through a glass slab. এখন গ্লাস স্ল্যাব লৈছো, মানে এখন কাচৰ টুকুৰা এটা লৈছো, এই টুকুৰাটো ৰিফ্ৰেকশনৰ কথা আমি পঢ়িম। সো লেট মি সি, দিস ইজ এ ৰে, EF is a ray which is entering from air medium to the glass medium. So as we are studying only refraction, I am not taking the reflected part. I will be only studying the refracted part. So EF is an incident ray. It will refract to another medium, that is the glass medium, from air to glass, and from now this ray O dash will again come back to the air, that is it will refract from glass to air. Eta moi ray loisu EF to ki korise ei transparent medium tur uporot porise, porar loge loge ei EF to e রিফ্ৰেক্ট হৈ কেনে গ্লাস মিডিয়ামৰ ভিতৰত সোমাই গৈছে। এতিয়া তাত এটা কথা আছে, ৰিফ্ৰেকশনৰ ক্ষেত্ৰত এডাল মোৰ নৰ্মেল মানে এই ট্ৰান্সপাৰেন্ট মিডিয়ামটোৰ ওপৰত এডাল পাৰপেন্ডিকুলাৰ। সো যেতিয়া ইনসিডেন্ট ৰে আহিছে, এই এয়াৰ মিডিয়ামটো লাইটাৰ মিডিয়াম, গ্লাস মিডিয়ামটো ডেন্সাৰ মিডিয়াম। সো লাইটাৰ মিডিয়ামৰ পৰা যদি ডেন্সাৰ মিডিয়ামলৈকে যদি ৰে সোমায়, তেতিয়া মোৰ ৰেডাল বেন্ড হৈ টু নৰ্মেলৰ ওচৰ চাপিব, আৰু যেতিয়া ডেন্সাৰৰ পৰা ৰেয়াৰ বা লাইটাৰ মিডিয়ামলৈকে যায়, তেতিয়া হলে মোৰ ৰেডাৰ নৰ্মেলৰ পৰা আঁতৰি যাব। So ইয়াত কি হৈছে EF এডাল ৰে ট্ৰান্সপাৰেন্ট মিডিয়ামটোৰ ওপৰত পৰিছে পৰাৰ লগে লগে এই যোনটো O ডেছ হি যাব লাগিছিল এইটো ডটেড পাথটোই দি কিন্তু গৈছে নৰ্মেলৰ অলপমান ওচৰেদি তাৰমানে যেহেতু ৰেয়াৰাৰৰ পৰা ডেন্সাৰলৈকে আহিছে সেইটো কাৰণে ৰেডালে নৰ্মেলৰ ওচৰ চাপিছে সিমিলাৰলি এই ৰেডাল আকৌ গৈছে গৈ কিনে এই ট্ৰান্সপাৰেন্ট মিডিয়ামটোৰ ওপৰত পৰিছে পৰাৰ পিছত আকৌ ৰিফ্ৰেকশ্যন হৈছে এতিয়া মোৰ ডেন্সাৰৰ পৰা ৰেয়াৰাৰলৈকে গৈছে যেহেতু ডেন্সাৰৰ পৰা ৰেয়াৰাৰলৈকে গৈছে এই ৰেডাল নৰ্মেলৰ পৰা অলপ আঁতৰি যাব লাগিছিল এনেকৈ যাব লাগিছিল হি অলপমান দূৰে দি গৈছে সো এইখিনিয়ে হ'ল ৰিফ্ৰেকশ্যন থ্ৰু এ গ্লাছ স্লেব বাকি এংগল I1 টো হ'ল মোৰ ইনসিডেন্ট ৰে R1 টো হ'ল মোৰ ৰিফ্ৰেক্টেড ৰে সো এইটো I2 হ'ল মোৰ সেকেন্ড ইনসিডেন্ট এংগল R2 টো হ'ল মোৰ সেকেন্ড ৰিফ্ৰেক্টেড এংগল সৰি এইটো ৰিফ্ৰেক্টেড ইনসিডেন্ট এংগল এইটো ৰিফ্ৰেক্টেড এংগল এইখিনি কথাই মই ইয়াত লিখি দিছো Now let us go to the law of refraction of light. Similar to the law of refraction are also of two types. That means there are two types of law of refraction. First one is same as that of reflection. The incident ray, the refracted ray and the normal to the interface of the transparent medium at the point of the incident all lies on the same plane. So, you will understand this point while looking at this diagram. So look, this is the incident ray, this is the refracted ray and this is the normal. This incident ray, refracted ray and normal all lies on the same transparent medium. This is our first law. My second law is the sine of angle of incident to the sine of angle of refraction is a constant for a given medium. So, this sine I into divided by sine R. Sine of angle of incidence by sine of angle of refraction is a constant. And this constant will be different for different medium. If I take glass, this constant will be different. If I take air medium, this constant will again change. So this is a constant and will be same for glass, same for air, but will be different if the medium changes. This second law of refraction is also known as Snell's law. So what is Snell's law? It is nothing but the ratio of sine of angle of incidence to sine of angle of refraction is a constant for a given pair of medium. This constant has a name and that is this constant can be called as a refractive index. So this sine of angle of incidence by sine of angle of refraction is nothing but the refractive index. So here I will be studying what is refractive index. I will be denoting refractive index by Ri. So Ri means refractive index is a constant quantity and is denoted by n. So n is the refractive index and as we have studied earlier, n is nothing but sine I by sine R. This is one equation of refractive index. It is the ratio of sine I by sine R. Again, let us consider a ray traveling from medium 1 to medium 2. We can consider the same figure 1. One ray is traveling from one medium to another medium. If V1 is the speed of light in the medium 1 and V2 is the speed of light in the medium 2, then also refractive index can be written as speed of light in medium 1 divided by speed of light in medium 2. And here, since light is traveling from medium 1 to 2, so n is written as n to 1. Means first light is traveling from medium 1 to medium 2. This is also one expression of refractive index. Here V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2. Similarly, if the medium if the refractive index of medium 1 with respect to 2, if we are studying that light is traveling from medium 2 to medium 1, refractive index of medium 1 with respect to medium 2, we will write what? N12. Refractive index of medium 1 with respect to medium 2. Here, here also it is the expression is same, but it will be opposite one. The speed of light in medium 2 divided by speed of light in medium 1. Here speed of light in medium 2 is denoted by V2 and speed of light in medium 1 is denoted by V1. So if we consider medium 1 to be air or vacuum, if medium 1 means V1 is air or vacuum, then that refractive index is said to be absolute refractive index of the medium. Means if light is incident from air to another medium, if light is incident from air to another medium, then for example if light is incident from air to glass, then we will say that it is a refractive index of glass or absolute refractive index of glass. So what is absolute refractive index? If one medium is air or vacuum, then that refractive index is called absolute refractive index of the medium. So absolute refractive index can be denoted by Nm. It is nothing but speed of light in air divided by speed of light in vacuum. Speed of light in air, we all know that we are denoting speed of light in air by c. So c is the speed of light in air and v is the speed of light in vacuum. This is another expression of absolute refractive index of the medium. Absolute refractive index can also be called as refractive index. So sometimes we are calling it only as a refractive index. We are not calling it as absolute refractive index. So absolute refractive index can also be called as refractive index only. So in your book, in page 175 and table number 10.3, there are several values of absolute refractive index given. So please look, go through that values. Okay, I am completing my video here. Thank you.